So if that's possible, then we can start.
Okay, good. So just some quick introductions, so you know our roles and we would know your roles, and then also if there's anything in particular that you would like to make sure that we cover during today. I mean, really the meeting is for you and to make sure that we're covering things that are important to you. My name's Bob Cooper. I manage sales for Sparkling Logic. Also on with me is Colleen McClintock. Colleen is our Vice President of Products, and she's going to be part of the discussion, doing the overview, and also giving us a product tour of Smarts. So I'll turn things over to you now, and if you guys could introduce yourselves and just what your roles are at UST Global, and then if there's anything in particular that you want to make sure that we would cover today that would be of interest for you, and then we'll get going with the overview.
Hi, Robert. This is Anil. I work with the modernization services, legacy, especially legacy modernization. So myself and Mini are the same group under the IBM related modernizations. And
you said
Raj,
IBM related?
Yeah, mostly IBM related. So either mainframe or AS founded. We also get involved in the other modernization, means older versions of Java to a newer version, or from a Delphi platform to other platforms, or language conversions and platform conversions. So that's what our roles are basically.
Okay.
Myself and Mini. Raj from the application development side, so he also gets involved in all the modernization related projects. Mandra is there. Mandra, can you, Mandra?
Yeah.
Yeah.
So I'm part of the big data and advanced analytics services, and so basically probably because of the decision driven. So I'm interested more from the perspective of on how you are using insights to drive decisions, and how legacy. What do you understand by legacy, and how all of what is the scope of your product and solution?
Just after you said scope, I couldn't hear what you said after that, Mandra. Scope of?
Yeah. So, yeah, what is the scope of your product and the solutions around it?
Okay. All right. So
Bob, this is Jairaj. I think my mic got fixed.
Okay.
I'm able to. Hope you can hear me.
Yep. Yes.
Okay. So I'll quickly introduce about myself. I work in the same team where Rajkumar works as well, in the services and solution and application development area. Work as an architect, mainly in the J2E side. I also help in the modernization and in the UI part of the application.
Okay. Okay, very good. So just to let you know, what we had planned to do was, we know that there's some interest in modernization and how people could use Smarts as part of a toolkit for that. And Raj had also told me there was interest around just how we work with data and analytics. And so we thought we would do a general overview of the platform so that you'll know how we are sort of placed and what we do as a decision management platform, and then get an understanding of the product. We've not forgotten about the modernization and the analytics, let's say, sort of slant to things, but we want to make sure you have some basic understanding of the product. And then if there is a specific follow-up that would be like a next step, oftentimes customers will say, well, I want to talk more about a deployment architecture. So we'll do a specific discussion, presentation really around the options that you have for a deployment architecture. You may have something you want us to do for follow-up that goes deeper into how we use analytics inside the product and how we can also bring analytics in from other platforms using PMML. And you may want to talk specifically, third thing about how have customers used this in more detail for modernizing an application and this sort of data first approach that people can take. So just because we're not going to drill right into that right away doesn't mean we don't want to do it. We just want to make sure that you have a pretty good understanding of the product going forward. Interrupt us for questions, please, throughout the time. For me, I do not have a hard stop at the top of the hour, but I know that it's late. I'm not sure if you're all in India, but for those of you that are, I know that it's late there, so I really appreciate you guys spending the time with us this late in the evening. And if we have to run over, then I think that I know I'm okay with that. And Colleen, I'm not sure if you are, but if we have to run past the top of the hour, we can do that, I think. Okay.
This is Rajkumar on call. Sorry, I got stuck with some connectivity issues.
Hi, Raj. How are you?
Doing good, Robert. How about you?
Fine, thank you. So we've gone, I didn't see when you had joined, but we've gone through everybody's introductions, and you probably just heard me talk about what we're going to do for an overview. Is there anything in particular you want us to make sure that we do cover today, or spend a little extra time on?
No, I'm fine. I joined when everybody was introducing, so sure.
Okay.
That should be fine for me.
Okay. So, Colleen, you there?
I'm here.
Okay. I've given you presenter, and everybody should see a Sparkling Logic logo and looking like a slide. Anyone cannot?
Okay, so I'm just, can you guys see?
Yes, we can see that.
Okay, so I'll just go through a quick overview of Sparkling Logic, and then we'll go into a demo. So Sparkling Logic is a decision management and platform, which means it is combining business rules and predictive analytics. And we were founded in 2010 in Silicon Valley, and shortly after the product was introduced to the market, we were named a cool vendor by Gartner for the innovations in the platform. And the objective of the product is to empower organizations to be able to dynamically adapt, evolve, and optimize their business decisions. So this is just kind of a high-level overview of Smarts, and Smarts includes a analytics or an analyst workbench that is accessed through a browser where business analysts can author, test, and validate their decision logic in the form of business rules. And the decisions can be deployed, and they're stored in a repository and deployed to a decision service. And the decision service can be accessed or invoked by your processes or systems at the point in time when a specific decision needs to be made. And the access is through a REST API. So the system that invokes the decision service passes data in the form of what we would call documents in the product, and the document structure defines the inputs and outputs from the decision. And the decision service executes the decision logic or the business rules and analytics if the system includes analytics, and returns the document that's populated with the decision results to the invoking system. And Sparkling Logic can be delivered either on the cloud or on-premise as a virtual appliance. So the business rules, of course, are key to defining a decision, and Smarts defines a high-level decision flow that defines the sequence of the way that the rules will be applied. So you can also use a feature in Smarts called Red Pen that allows you to point and click in the data directly into the form to write business rules without learning a special language. Or there's also an IntelliSense editor that will let you write the rules using autocomplete directly from the data in the form. The predictive analytics capability built into the product is a capability to allow you to use some machine learning algorithms to induce business rules from current and historical data, or you can import PMML models that can be executed and tested in the context of the decision. So the PMML import, so we also have a PMML engine that would allow you to operationalize analytic models. A key feature in the product is the ability to define KPIs or metrics so that you can measure the business performance of a decision, the quality of a decision. So by defining these KPIs and metrics, as you develop your decision, you can measure the results in the dashboard using these reports to see if the decision is producing the desired outcomes. You can also of course measure after deployment. So the idea is that by defining KPIs and metrics on the decision from the beginning, during development, you have the quality of the decision or the business impact of the decision in mind as you develop the decision, and of course you're going to continue to monitor after deployment. And the ability to combine rules, analytics, and experiment and measure the results in the context of data is something that's unique and innovative in the product. For deployment, we have a number of different deployment options. Of course, you can deploy on the cloud, and you can it's invoked through Java or .NET as that just basically wraps a REST API. You can also deploy as a decision service and embed the engine directly in your Java or C or .NET application. So the overall process that you would go through, the activities that you go through inside of the Sparkling Logic Analyst Workbench is to either extract or define decision logic, always in the presence of data. So if the rules are coming from data, then you can actually use these machine learning algorithms. Otherwise, you write the business rules based on expertise or based on legacy code, and you can visualize the results of the business rules in the dashboard through reports, and when you're ready to, you can deploy. And again, the deployment can be either on-premise or in the cloud, or finally it can be embedded as a component directly in an application. So I just want to talk about quickly just a few use cases of customers using the product. So PayPal, of course, is an online payment processing company, and they use Smarts to fight flash fraud. And flash fraud is rapidly changing fraud that arises on a regular basis, high volume fraud. So the losses, they were experiencing losses because of the lag time between when they would identify new fraud cases and how long it would take them to put fraud prevention measures into production. And it used to take them 15 days to identify their fraud and put new measures into production to monitor for that new fraud scheme. But using Smarts, they were able to reduce this from 2 weeks down to a single day. And of course, they're saving tens of millions of dollars in the process by being able to detect fraud earlier. Equifax.
I
Oh, go ahead.
Yeah, I have a question here. So, for instance, if we are looking at something like a fraud, right? And here, so is there a feedback mechanism that the engine would also support? So, for instance, when we are talking about a false positives or something like that, that machine learning algorithm might throw up?
So,
I'm not. What?
I was just going to say, Mandra, could you give an example for like a call center example of what you're thinking about?
Yeah, so for instance, we are talking about fraud, right? So the machine learning algorithm might throw up a probability of a fraud based on something, right? So based on the truth table, it might be a false positive or a true negative. So in which case, which will be after the fact, right? Like you might have so two scenarios where you might have identified a fraud where fraud did not happen, or you might have not identified a fraud which actually was a fraud. So is there a way by which the feedback mechanism can be pushed into the system so that the learning algorithm can also can basically self-learn on the wrong predictions?
So PayPal doesn't use it. It doesn't. So that would be. I don't. That what you're talking about is automatically updating the algorithms to detect the fraud, right? Automatically updating the models, correct?
Probably that might even happen later. That totally depends on the machine learning algorithm. But like, is there a way by which actually probably we don't understand how it works with the data, but like there is predictions have been made, right? Like a decision was made based on something that was identified. Whether that decision was true, correct or not, is that something that can be
Yes.
fed back into the system?
Yes, exactly, and that's what PayPal does. And so initially, when they first have new fraud schemes, of course, PayPal's unique because the way their fraud is initially detected is a customer, reports fraudulent transactions on their account. At that point, they don't have a lot of data. So one of the unique things in Smarts is the ability. Of course, they have a lot of models that they've developed over time to detect fraud. But the piece of the product that they use called BluePen is able to do is with lower volumes of data, they boost the signal of those fraud cases and run against less data than they normally would to train a model. And they run all of these jobs. They set up all of this in a task flow, and these jobs, lots of different machine learning jobs run to build these models, and they produce reports on the catch rate and the hit rate, which is what you're talking about, whether or not, did they catch the actual cases of fraud that were reported versus, or did they have too many fraud cases that they identified, because they want, obviously they want to minimize the disruption of cases that aren't truly fraud. So at that point, once they're satisfied with their ratios and they use all the dashboard reports to do that, then they deploy the new model into production. So they continuously adjust and improve on basically a daily basis. So I'm not sure I answered your question, but their dashboard reports, you have to have historical data to tell you whether or not the case that you identified as fraud actually was fraudulent, right? So that gets fed back into the system to improve the model. And does that make sense?
Yep.
Okay. So Equifax has a platform called Interconnect, which is a solution for automating account openings and credit risk decisioning, cross-selling. They also do fraud, and they're used by 30 of the top 40 banks and 4 of the 5 top telecommunications companies, and more than 1,000 customers in Canada and the United States use Equifax. And Smarts, Sparkling Logic, is the decision engine that is part of the Equifax Interconnect platform. And then finally, I'll talk about First Rate. They're a joint venture between the Bank of Ireland and the Post Office, and they're the UK's largest foreign exchange supplier, and they selected Smarts as an enterprise solution to support their plans to diversify their customer and their product and market coverage. And they have 2 deployed applications. One is fulfillment, so they use Smarts to optimize their stock levels of foreign currency at their 11,000 post office branches. And they also have a pricing application that they use to support a cross-channel pricing service so that they can provide quotes for foreign currency requests. So those are just a couple of examples, and I'm not, you know, we could go into more, but I think the best thing to show you is a demo of Smarts. And one of the things that is unique with Smarts is the ability to work in the context of data, so that as you write rules, you can immediately test and execute those rules. And also, you can modify what we call the form. So inside of the product, you're able to dynamically add new fields or computations and use those fields as you write rules. So I'm going to show you just a very quick demo of how you kind of get started with a new project in Smarts. And the reason I'm going to use that is so that when we go to a more full-blown demo where all of the data and KPIs and metrics have been defined, you'll have a context of how it got set up in the first place. Is that okay?
Yeah, carry on.
Okay. Okay, so when I log into Smarts, I'm now in my browser, and you can see I'm in an area of the product called the home page. And the home page is basically just going to show me all of the projects that I have in my workspace. So I'm going to go in and open an empty project that I have. And this project, the purpose of this project is just to give a quote for auto insurance. So I start on the project tab, and inside of this project I don't have anything. I have no decisions defined. The form basically is the business object model, or the structure. It defines the structure of the data. And then data, the data area allows me to import data samples that I can use to test and execute my decision. So I could start by defining a decision and start writing rules, but instead I'm going to start from data. So in this case, I'm going to import a new data sample, and I can do that by clicking on data and selecting a file. So I'm just going to import a set of insurance applications, and Smarts can import JSON, XML, and CSV files. So when I import my data, Smarts is going to give me a preview of what's in that data. So I can, if I collapse, I can see all of the sections on the insurance application that I'm importing, and I'm able to do some limited customization on an import. I can change the names of the field if I want. I can change their data type. If I have any problems here, if there's not enough data to infer the data type, then Smarts will give me a message, and I can set the data type. But I'm just going to accept the defaults here and go ahead and import that data. And once the data is imported, I get a message telling me the import was successful. So now I can open this data, and it takes me to the decision area of Smarts. And this is the area in the product where we write and test the rules. So here, let me just expand my screen here. So what I have over here, you can see that I imported 100 documents or 100 records. They're part of, they're just a bunch of auto insurance applications. if I collapse, I can see all of the sections, and these sections can be repeated sections. So I might have multiple drivers that are going to be covered on an insurance application. The same thing with vehicles. I could have multiple vehicles that are going to be covered. And then I have the type of coverage that they would like to request. So let me expand this now. So I can also scroll through and look at this data. So as I go through, you can see that the data is changing as I go and look at the various documents that I have loaded. So I'm going to go back to the first document. So where I write the rules, when I first start, Smarts by default creates a placeholder decision flow for me, and this is where I'm going to define the high-level steps for the decision. So in this case, we're trying to provide a quote for auto insurance. So one of the things I might want to do is define the steps to doing that. And maybe the first step that I'm going to go through is to add a check for eligibility to make sure that the drivers are eligible for coverage. So I can add a new step to my decision flow here. And when I do that, it creates automatically for me another decision step below and a rule set where I'm going to put my rules. So once I have a place to put my decisions, my rules, I can go ahead and start writing rules. Now I need a place to put the results of my decision, because I just imported a bunch of insurance applications and I don't have any area where I'm going to put the results of my decision yet. So I'm able to go in and modify the form, and I can add a new section, and I'll call this decision outcome, and this is where we'll put the results of the decision. And then I can add a field, and we'll call this status, and status will be whether the application is approved, declined, or referred. And then I can just copy that field, and I'll create another field here where I can give I can produce a message, and this message will just tell why we made the decision we made. So once I do that, I can simply start writing rules. So the first rule that I might want to write, let me open my eligibility decision step, and I can say I want to add a new rule here, and perhaps this rule is going to make sure that the driver is old enough for coverage. So we're going to write a rule to catch those drivers that are too young. So I'll just call the rule too young. I'll give it a name. And then I can start to write my rule. So I want to find drivers who are under the age of 16. So what happens when I define this rule is you can see that I have an error because age is not yet defined. And if I go and look at my applicant, I can look at the primary driver here, and I can see that I have a date of birth for this applicant, but I don't have any field called age. So the other thing I'm able to do now is add a new field and use this to compute age. So I'll add this field called age that I wanted to reference in the rule, and then I can define this as a computation. So I'll go ahead and define that age is an integer because it's a number. And here, I'm going to compute the age from the date of birth. So I'm going to take the current date, and that would be today. And I'll take the year of today, and I'll subtract the date of birth year. And when I do that, now that I've defined that computation, you can see that the error goes away. So I can say if the age is under 16, then the status will be denied. And I want to create a message that says that they are too young. So, oh, there we go. So once I write that rule, and because I have data here, I can immediately execute the rule. So all I have to do is hit the run button here, and it will tell me that this rule, as I wrote the rule, one of the things that SMARTS does is it highlights the fields that I'm referencing. So I can immediately, once I have a lot of rules, I can immediately see which fields are used by my rules, and the heat map, the length of the heat map will give me a visual indication of how frequently they're used. Now, in this case, I only have one rule, so it doesn't really, it just highlights it as the same length. So I see age was used in the rule, and then my status and message was used. So here, this rule didn't execute, but we can go ahead and test the rule by saying that we want to change the driver's birth date. So I can also change the data as I write rules if I want to make sure that the rule is working properly. So in this case, we'll say that we're going to change the year. Let's change the year to 1999. Or maybe I need to, let's see, 16, so I need to change it. I better change it to 2001 to make sure I get ahead. Okay, and then I can execute the rule, and what will happen now is SMARTS will, you see the rule did execute. I have a heat map that tells me how many times the rule executed for my 100 cases. Since I didn't have any before, I know that this will be the only case now. I can collapse my form and look at my decision outcome, and now I have my results. So I wanted you to see, before I go into the full demo, how you get started in SMARTS and how easy it is to begin writing rules and testing, because you're always working with some test cases. And you can also create these cases on the fly as you go by adding a new document. I can also add a copy of this document. So maybe I'm going to write another rule, and I'm first going to create a test case for that rule by copying an existing document and maybe changing some of the data. So it's a very productive and easy environment to get started in. And I'll pause for a minute to see if you have any questions before I go to the next demo. No questions?
Colin, Jairaj here. So you mentioned that the tool supports the data to be imported using either a flat file or CSV.
Yes.
Does it support import directly from any of the DB, or it has to be a file like JSON?
No, you can also, so keep in mind that the data that we're using right now is data that we're using for authoring and testing decision logic. And it can, if you have an external data store that you would prefer to pull this test data in, this data to author the decision and test it, you can do that. So you can also instead point the product to an external service to retrieve the data and bring the data into the environment for during development.
Okay. Sure.
Okay. So yes, it can access external data. Now, but keep in mind, so that because data is brought into the authoring environment, that's different than accessing external data once you deploy. We can also do that. I just want to be clear that right now, even though we're executing, we're in the development phase, right?
Sure. Yeah, it makes sense.
Okay. So I'm going to go back and open another project, and this project is a full-blown project that's fully defined, and you'll have a better context for it now. And I'll start by going in and opening one of my data samples. So I've got 3 data samples defined here, and I'm going to open my renewal data sample. Okay. So in this case, again, I just simply imported 100 documents over in my data area. My decision is down in this bottom pane. I can see that I've got a decision flow, and now the decision is going to go through a number of steps. It's going to validate my input, my application, apply some eligibility or knockout rules, do some risk-based tiering, and then finally do some pricing or rating rules and accept and quote at the end. So I have a full-blown decision here now, and the other thing that's different that you haven't seen is I've got these reports in the dashboard. So here I have a report that shows me out of my 100 applicants, how many were approved, how many were referred, and how many were denied. I also have reports that allow me to report on something more interesting and a little more sophisticated. And here I can see, based on this current data sample, what's my current profit margin, how much is my total premiums, what's my profitability, and I can see that with the current decision logic that I have, we're losing money on certain cases, those that are in the bronze and the gold packages. So what I might want to do now, and what I'm going to show you now, is how you can make changes to your decision logic and measure the results in the dashboard to see if you're headed in the right direction, okay? So I'll go back to my normal reports, and I'm going to come over and look at my data here, and these are renewals. So the way we're computing whether or not they're losing money is if they have higher claims than we charge for a premium, then that represents a loss. So in this case, I can see that on this particular applicant, I do have losses. And I might want to understand a little more what's happening in this case. So I'm going to look at my decision outcome, and I can see that we've approved this particular applicant at standard risk. And I might want to understand which rules executed and how we came to that decision. And I could just go through my rules. I can even do things like apply a filter to show which rules applied to this case. But I'm going to use a feature in the product called Red Pen that will allow me to explore the relationship between the rules and the data. So when I turn on Red Pen, it collapses the rules to just their rule name. And I'm going to come over and say that I'm interested in risk level because I want to understand how we determine the risk on this applicant. So when I pin risk level, I can also apply a filter that says only show me the fields that are using risk level. And when I do that, I see these are all my risk rules. These that are highlighted in blue are setting the output. So I know that this rule set here is what set the output for risk level. These other rules in orange are using risk level as an input. So for fields in my document that are used as both inputs to the decision and then also used that are set in the decision and then used also in subsequent steps, those are going to be highlighted in both orange and blue. So I know the rule that I'm interested in is going to be the rule that executed on this document, and in this case, I have a green indicator that tells me that this standard risk rule is the one that executed in this case. I can open and look at the text of that rule, or if I want to, I can simply pin the rule, and Smarts will show the rule back to me in the context of the data. So when I open the sections where the rule is indicated, I can see that in this case, we're looking at the age of the drivers to see if they're between 25 and 45, and they are. In this case, our data says 39. Therefore, we're making a determination that this is a standard risk case. So in Smarts, I'm able to make changes to these rules by either typing in the rule text area, or I can simply point and click and make changes directly in the red pen representation. So this is a case where what I might want to do now is I could use the machine learning capability in Smarts, Blue Pen, use maybe a larger data sample and try to induce some rules, identify some characteristics in the data that might indicate that this is a risky case, and I could use Blue Pen to induce a set of rules and import those into the decision and see if that works better. So this is a demo we can show you another time. but right now I'm going to proceed just based on expertise. And what I might do now is look through all of my data and look for other characteristics in the data that might tell me that this case is a risky applicant. And one of the things I might notice is that this case has 3 accidents, and 3 seems like a lot of accidents. I could go ahead and modify the rule and add accidents, take accidents into account. But I might not be sure right now where I want to set this threshold for accidents. So I know that 3 sounds like a lot of accidents, but what about 2? Where should I set the threshold in my rule? So I'm not going to modify the rule just yet. Instead, I'm going to put down the red pen, and I'm going to show you how you can use data to help you determine where to set a threshold. And I'm going to create another report by just dragging this accidents field to the dashboard. And when I do that, whoops, wrong field. I meant to drag accidents. Sorry about that. So when I drag a field to the dashboard, what happens is Smarts will automatically create these dashboard reports for me. And based on this report accidents, what I can see is that about 60% of the cases fall under 3 accidents. So it looks like setting the threshold at 2 or more accidents would be the right place. And if I'm not sure, I can go over and load a different data sample. So let's load the new business data sample. When I load it, it's going to automatically refresh the dashboard reports. And the numbers are different, but still about 60% of the cases have under 3 accidents. So once I'm happy with where I want to set that threshold, I can go back to my renewal data sample. And I'll go back into red pen, and it will remember where I left off. And now we're going to go ahead and make the change. So I'm going to collapse the form. I can see where the rule is represented. And now I'm going to go ahead and use red pen to make this change. So I'm going to take accidents and take them into account. Instead of 3 accidents, I'm going to see all of those cases that have 2 or more accidents. And let's set the risk level up a little higher. So instead of standard risk, I can set these to medium risk. And once I've made that change, I'm going to go ahead and put down the red pen. And now I'm ready to execute and see if it makes any difference, that small change. Before I do that, I'm going to take a snapshot of my current execution, and I'm going to call it before changes, so I can do a comparison of before and after my changes. So when I take that snapshot and I go ahead and execute, what I can see is I didn't change any of my approvals because the change didn't have any impact on that. But what it did change is, if I look at risk level, which is directly where I made the change, you can see that we're currently, that after that change, we're just a simple change. We're moving some of the cases from the standard risk bucket up to this higher medium risk bucket. So I can see my before changes execution in blue and then after in red. Now I can also go and look at my dashboard reports, look at my KPIs and metrics in the dashboard, and what I see here is this is my before and this is my after. We're still losing money, but we're losing less than we were before. And I can see my profit margin went up. So in Smarts, as you make changes to your decision logic, you can measure the results of those changes in your KPIs and metrics in the dashboard. So you can also run much larger simulations. Right now we're working with just a small number, of documents, a small amount of data. If I have a large amount of data and I want to run a simulation asynchronously, because it might take more time to execute, I can launch a simulation and run this on the server side. And then when the results are done, I'll get my dashboard reports and I can go and take a look at them. So in some cases, you might want to test using much larger amounts of data. And SMARTS also uses a general purpose built-in map reduce algorithm, so you're able to compute these metrics very quickly, even for millions of documents, so for very large data samples. So the other thing I want to show you is we've been working with these risk rules. I'm going to go back. I can use my decision flow to filter to specific areas in my decision. So I'm going to look at these rules that we've been modifying based on risk, and these were in my tier assessment decision step. When I click there, it filters to those rules in the pane below. And one of the things I notice is that all of these rules, all they're doing is looking at average age and total mileage. So they're basically all doing the same thing. They have a similar format, and they're setting risk level based on that. And when I have a lot of rules that are similar in structure like this, I might want to look at those rules in a different representation. So I'm going to change my representation to a decision table. One of the things that is unique in SMARTS is we don't force you to pick a representation up front. You can write the rules in any representation and change them as you want to. So I can look at the same rules as a decision table, a tree, a graph, or as text-based rules. So here I have my tiering rules based in a decision table, and of course each row represents a rule, and every column gives me the values of the conditions that I'm testing. This is an editable representation, so I can go in and change those values. I can also add new rules by adding a row. I can add new conditions or actions by adding a column. The other thing that the decision table representation lets you do is sort. So if I click on my headings, I'm able to sort. And of course, this is not a very large decision table, so it's not too important to be able to do these things. But some of our customers have very large tables, and they need to be able to do things like sort. And you can also group. So if I want to see, if I group by total mileage, what I'll be able to see is all of the rules that don't take mileage into account, the rules that look at mileage under 50,000, and the rules that look at mileage over 50,000. So the sorting and grouping is helpful when you have, of course, a larger table than we're looking at right now. Now, because this table has a lot of white space and is somewhat asymmetrical, I also added this accidents, taking a new field into account, and there's lots of white space there. So another representation that might be helpful when you have an asymmetrical table like this is to look at the rules as a decision tree. So I changed the representation to a tree, and I'm going to go ahead and swap my panes and expand so you can see. So in the tree representation, each rule is a path from the root to a leaf node. I still get I get the heat map information at the bottom that tells me how many times the rule executed. But the other thing that's unique about a table representation is I can see how many times each of the conditions in my rules applied. So I can see that in this case, 29 out of my 100 cases had mileage under 50,000. It's an editable representation. I can add new conditions by adding new nodes. I can modify, I can change a condition by modifying an existing node. So I'm able to write rules and view rules in these different representations. Because the decision table representation has a unique path for every rule in the rule set, I might want to try to understand how we come to specific determinations. So for example, here I have a rule, this path leads me to a standard risk determination, and I've got another path at the far right that also leads to standard risk. So if instead what I'm interested in seeing is all the ways that we determine an applicant is standard risk, what I can do instead is look at this representation in the last one, which is a decision graph. And the decision graph is going to combine the common nodes so that I'm able to select a subgraph. So for example, if I want to see all of the ways that we determine applicants are standard risk. I can look at that specific subgraph and see the two paths that lead to that determination. So this feature is useful because it allows you to write and work with rules in either the representation that's appropriate for the task at hand or the representation that you're most comfortable with. Now I'm going to switch my panes back to where they were. Do you guys have any questions before I go further? No? Okay.
Carry on.
Okay. So maybe the last thing that I could show you is well, you already saw that you can also write rules in text. So from here, I think I would like to get feedback from you guys on any questions you have or what you'd like, anything else you'd like to see.
Most of what you have shown is available in similar kinds of products, right? Like IBM's ODM has similar. What we wanted to actually see was how it applies analytics, is able to reverse engineer the rules and so on. So if you could show something around that, to be useful.
Can you repeat? It's kind of hard to hear you. Can you repeat what you want to say?
I was saying if you could show us something around the analytics piece where looking at the data it is able to infer rules. We would like to see that aspect of the tool.
Is that Raj speaking?
Did you say?
Yes, sorry
yes.
about my connection.
It's okay. So I can, Colleen, I can hear. So originally Raj said this looks something like things you could do in ODM. Now could you cover how you would use analytics and machine learning as part of the process to help drive decisions?
Sure. So one thing you can do is, of course, we can import PMML. And if I look at my my project area, I've got the ability here to simply import a PMML predictive model. And once I import a PMML model, I'm not going to show this right now, but because I'm going to show Bluepen instead. But what you can, when you import a PMML model, you can then come over to a specific rule set, and you can actually apply a model in that rule set, and you'd have to map the model input fields would of course have to come from your data, and you'd also map the output to some field in your document, and then the model will execute at runtime. So you can import PMML models is one of the ways you can work with analytics. The other way is a feature in the product that we call Bluepen. So if I go into Bluepen, of course, what I'm going to want to do if I'm going to work with Bluepen is I'm going to need to work with a larger data sample. So I can either switch my data samples, or I'm able to, when I work with my data, I can use a larger data sample to induce my rules. So I forgot to switch my data sample, so we're just going to go. Let's see. Let me go back. Let me put down Bluepen, and I'm going to load a larger training set of data now. And what happens is smarts will load. You can actually load in the tens of thousands of documents into this environment. But if you go larger than that, you probably want to load to the server side or access externally. With about 10,000, or somewhere between 10 and 40,000, it will run in the browser. But when you go beyond that, you need to load it to the server side or access an external an external data source. So in BluePen, now that I've loaded a bigger data sample, let me go back into BluePen. I still have my data, but it's shown in the format of a data table. And in the data table, what I can, in order to make it look recognizable, I can go ahead and group it by section. Then you can see I've got all the various sections from my data. And what I'm going to be trying to do is I'll go through the case that we talked about earlier. Maybe I want to induce some rules to predict risk. So I want to use, instead of writing the rules, I want to use machine learning to find some rules that will predict risk for me. So the first thing I need to do is tell Smarts what I'm trying to predict. So in this case, I'm going to be making a prediction based on claims. So I've got a field where I'm going to, I've got a field in my data where I have a risk indicator that was set based on the claim amount. So that will be my field in my historical data that I'll be trying to predict. And I then need to tell Smarts where I want to put the output from that data. So in this case, I'm going to put it, I need to put it in my decision outcome section, which is here. And I'm going to put that in my risk indicator field. So I've set two fields: a target, where I want to, what I want to use to predict, what I'm using to predict, and then my target field. And then I need to identify other fields that I want to take into account when I run my machine learning job. So in this case, you know, I could go through and select fields that might be related and might be predictive of risk. So, for example, I might want to take my total accidents field, for example. So now I'm able to just select certain fields that I want to use to train the machine learning job. So I'll take maybe total accidents, and then maybe I'll select some other fields. Maybe I'll take the maximum accidents field and the total mileage. I'll take total mileage and maybe average age. So I'm just selecting certain fields that might be helpful, that I might be able to take into account. If I want to get an indicator of how those fields might be related to my target, I can recompute based on the data that I have, and I can, let me get rid of this section here, and I can organize, I can compute quickly a field called a Gini gain, which will give me an indication of the predictive power of that particular field. And let me get rid of my grouping here. So if I sort by Gini gain, what you can see is, of course, the claim-based risk indicator where I have my historical data. Of course, that's a perfect prediction. That's going to be a 1. And the closer I am to 1 on these other fields gives me an indication of their predictive power. So I can also look at things. I've got certain information I can use to explore the data. I can look at, if I open a field, I can see a basic statistics, what the minimum and the maximum values are, how many fall into the 25 percentile, 50%, 75 percentile bucket, the average, the standard deviation. I've got a correlations table that will show me how this is correlated to my claims-based risk indicator, and a correlations chart. And of course, for data that isn't numeric, I've got, let's see if I can, I've got different ways that I can, basic statistics information I can use to explore the data. Now, the jobs that I can run in BluePen, I could have run a job to identify likely predictors that I should use, but instead I'm just going to use the ones I selected. So I'm going to go ahead and generate some new rules, and I'll just call these generated rules. I've got different algorithms that I can select, and I'm just going to leave the default here. For each of those algorithms, if you're a data scientist and are familiar with these algorithms, you've got advanced options that you can use to tweak them. If I hadn't switched to my training data sample, I could switch the document group here and say I want to run this job on a different data sample. If I had a server-side document group or a remote document group, I could use that here. And it shows me what I've selected, you know, what my target is, where I want to put the output from my prediction, and what fields I'm taking into account. In this case, because our data has certain cases that are checked out that are checked for eligibility, and not all of them have a quote, I want to get rid of, I can segment this data, so I want to make sure that I get those cases that did pass eligibility. So I'm going to use some segmentation here in my rule generation. And you could also use instance weighting to boost certain signals from the data if you have weak signals in your data. But in this case, I won't do that. And then I can go ahead and say generate rules. This runs on the server side, so I can continue working in the product and doing whatever I need to do while this job is running. And it should be done in a second. And once it completes, I'm able to open it and see what rules I've induced from my data. So I want to get those cases that did pass eligibility. So we'll be using these, and I can look at the rules. If I want to see what rules were induced, I can take a look at the rules, and I've got 21 rules here that the machine learning job has created. And these are one of the differences between using PMML and using Bluepen is Bluepen creates engineerable rules for you. So these are readable rules that I'm able to actually modify once I bring them into my decision logic. So let's go ahead and insert those rules. And I'm going to put that into one of my decision steps where I created a placeholder called risk assessment alternative. And once I do that, I can go ahead and go back to the other side of the product, and I'm going to go back to my renewal data sample. And
hi, Colin. This is Anil.
Yes.
Hello. Can you go back to the previous screen where you generated the rules, right? Can you just? I could not read it correctly, so can you just show it maybe in what's the generated form?
Well, okay. So in this case, they're just generated. If I go back into Bluepen and look at those rules, I can show you on the other side also. So here are the rules looking at the fields that I specified, the ones that it wanted to, that the Ripper algorithm wanted to use. So average age, and there's a test, and the total accidents, total mileage, and then it's going to set a risk indicator for me. Okay.
Can you make it larger so that I can just read? I cannot read it from the screen.
Yeah, well, I put it into a specific rule set. So let me go back and show you. Here, I'll show you where it is. So where I took those rules and I inserted them into a specific area in my decision flow. I put them into this risk assessment step, and I put them into a alternative risk assessment. Let me let me filter and show you the rules. So I put them here and risk assessment alternative, and then I can open and look at these generated rules. Oops, you know what? I think I put the wrong ones in there. Let me clear this out. I moved the wrong ones over, so I need to fix it. Here we go. Oh, this was there. It's at the bottom. So here, these are the ones I wanted.
Mm-hmm.
Okay, and then I'll go back to the other side, and I can see. So I'm going to delete these rule sets because I don't need them, and then I can open and show you the rules. So these are the rules that were generated from the algorithm. And they look just like regular rules. I can take them, if I want to see them, I might want to see these perhaps in a decision tree. So maybe I look at them as a decision tree instead. Okay, so these are the, and let me resize it to make it a little bit smaller so you can see them. So I know you can't read that either, but those are the rules that were generated. And if I want to, you know, so maybe it's better to see them in a text-based representation. So, but they're readable rules, and I can go in and the thing about Bluepen is because I've got these rules in a readable format, I can continue after I execute them. If I don't like them, I can tweak them further based on my expertise. I can also create metrics that I monitor on these rules so that I can see out of these generated rules which ones have the most contribution to my results, because maybe maybe some of the rules are more significant than others. And of course I'd want to test it with using different data samples and so forth before I made determinations like that. So let me...
Yeah, got it. But one of the typical problems that means we encounter when we try to re-engineer code is like when we are doing re-engineering, we have to extract the rules embedded in the code. So we were trying to look sparkling logic to identify the rules that are embedded in the code by looking at the data sample. So I think we are on the right track, right? Means that's what we are going to achieve, correct?
Well, so you can, that would be using, there's two ways you can do that. So let me go ahead and execute this, and then I'll show you a little bit more about how you can work with smarts if you're trying to run rules directly from data. Okay, so I'm going to get rid of my snapshot that I took earlier in the dashboard, and this is my current decision logic, and I'm just going to take another snapshot of my current logic, and this will be before I use Bluepen, before my machine learning.
Mm-hmm.
And just to complete the cycle on this task, I'm going to go ahead and execute, and we can look at the before and after with oh, shoot. So I need to tell smarts to run those jobs that I just created.
Colleen, while you're doing that, I'll just briefly describe a customer use case where we're essentially modernizing an application that was about 9 years old. Most of the code had been written in a scripting
Wait,
language.
let me go ahead and open up the project to show you a little bit about using data with legacy modernization.
Before
Okay.
you go there, just one question on Blue Pen. So I believe what we just saw was something like a decision tree, right? So are there what kind of algorithms are available on Blue Pen?
In Blue Pen, the algorithms, I didn't show you the algorithms. I can show you that. So the algorithms that I can run in Blue Pen are the RIPPER2, classification and regression, random tree, random forest, slipper, 1R, and then there's a streaming algorithm also.
Sorry, I was talking on mute. So whatever we use, we would get the coefficients as Gini gain, is it?
Pardon me?
Whatever algorithm we use, we would be using correlation factor as Gini gain, is it?
Yes.
Okay.
Okay, so this is a demo that shows you a slightly different aspect of how you would set up smarts, how we have customers using smarts for legacy modernization. And this is the same application, only we've added a little bit in terms of our dashboard reporting. So what you can imagine that I've loaded in is data, and I've got in my data, one of the things that I've got available is the results of execution from my legacy system. So from my legacy system, these are the results that the logic was producing. And what I would be trying to do is create my decision logic so that it matches the results that came from my legacy system as closely, I want to get to the same results in my decision that I have from my legacy system. So this expected decision outcome section is the results of execution from my legacy system, and then the actual decision outcome, so what my current rules are producing, is this section here, decision outcome. And I've got a metric that I created that will tell me whether or not my actual values match my expected values. And you can see that in this case, I have 80 that do match, but I've got 20 cases where we're not getting the same results as the legacy system. So what I can do is I've got some filters that that I define to help me narrow down to those cases that don't match. So for example, if I want to look at all the cases that don't match, I can apply this failed match filter. And now you can see now we're on document 2, and that we have these 20 documents that don't match. I can go through and take a look at the data in those documents. And, so for example, here we expected that this would get thrown, this particular case should have been thrown out on eligibility with a reason of need a cosigner. But what we actually got was in our current rules have approved this case, and said it was a high-risk case. So what I'm going to want to do is focus in on certain areas of the decision logic. So, for example, I know that this one failed on an eligibility check. So I've got other filters where I could apply that tell me find all of the cases that don't match for eligibility only. So I'm going to focus on eligibility first by applying that filter to look at only those like this particular case that don't match on eligibility. And now when I execute, I'll filter to just those that are eligibility cases. And you can see that now I'm looking at 11 cases where the eligibility of my legacy system doesn't match my current rules. So I see that this particular case in the legacy system got thrown out because it needed a cosigner, and we're actually approving this case. So if I go in and look at my eligibility rules, so let's just filter to the eligibility check, these knockout rules, and I can see what I've captured so far. So using smarts, usually the way our customers use smarts is they'll use smarts in addition to other techniques in mining rules from legacy code. So they might have captured certain rules from either documentation or from inspecting and identifying rules in the code and create some kind of a starting point. But I can see here that in this case, I should have had a rule that told me that I needed a cosigner, and instead I approved the case. So what I can look at is what my rule is doing now is looking for drivers that are between 16 and 18 and saying that they need a cosigner, and I didn't get that result. So I can go back on this case and I can look at my data. For example, I can say, let's look at the age on this particular case is 20, and my legacy system was throwing it out. So that tells me that the thresholds that I have here might not be the ones I want. So if I instead, let's say this one didn't pass, so if I say maybe in our legacy system I need to set my threshold higher based on my data, and I could create dashboard reports to help me do this, but let's say I make a change and I say that anybody under the age of 21 needs a cosigner, then I can go ahead and execute and see if that helps. And now this rule executes on this document. So what that's going to mean is that the case will now match. And if I look at my reports here, just that one change, now I have 10 cases that match and one that doesn't. So it tells me that, you know, that, and I would go through a process like this of looking at rules, looking at cases that don't match. I might want to look at my data a little more closely. So if I say, you know, what out of these cases that don't match, I could create a report maybe based on age. So if I create an age report in the dashboard, I can see what buckets, you know, what my age range is, and that can also help me decide where to set the threshold in a rule to match my legacy code. If I was missing a rule altogether, I would have the same kind of process I would go through, because I would be looking at the outputs. In this case, they're eligibility rules, so it's easy. If I had a message that was coming out from my legacy system that wasn't in my current rules, I would have to come up with a way to create the rules to match that legacy system, knowing that I needed something that said need a cosigner. Does that make sense?
Hello?
Hello?
Yeah, I got it. So it's like an iterative process where you'll try to filter, reach the expected output by adjusting certain parameters. So, and then in an actual project case where we want to find out the business rules used in the current system, we may have to go through each of these identified rules or these potential rules identified and then get verified by the current system specialists, right, or SMEs.
Yes. So you would start. I mean, you could start from the code itself, the legacy code itself, from documentation or from business experts, and start to capture some rules, put them into the product, and then start loading your historical data from the legacy system and seeing if you can, where you're off, where things don't match. You can also, if you don't have any starting point, you can, with enough data, you can use Bluepen to get a starting point for your rules. But even if you use Bluepen, you're going to want to, continue to experiment with those rules, comparing your actual results to your expected results. It's a process. It's exactly what you said. It's a process that you go through step by step, and Smarts just helps you do this comparison and narrow down as you go through the process.
Okay.
And Raj, just to sort of underscore the point Colleen had made about using Bluepen, if we were working with large amounts of data and large numbers of rules and so on, in this particular situation where there were mismatches, you could use Bluepen on those mismatches. So you may have actually got your original rule set from using some analysis tool that would, say, analyze COBOL or C or C++ and do some type of a way of creating a rule set from that as a starting point. And then, as Colleen had done, you could use, basically just analysis and looking at where the mismatches seem to be, what seemed to be causing them. But you could also use Bluepen to help derive where there'd be a correlation between where the mismatch was occurring and some other fields. I mean, here obviously we've got a dozen or so fields. It's not that many, but if you had a large number and you felt like there might be some correlation, you could use that. And that's generally what customers will do. It's a process where they'll use other tools. They take multiple steps. The most recent one, customer in New York, had a legacy system that they were using just under 1 million records as their way of testing the results. And they originally had, after generating rules from old code, they ended up with about a 40 to 45% mismatch, depending on what you used to do the matching. And they eventually got it down to less than 10 records were mismatches. And those records that didn't match, actually, they were found out to be errors in the old system and correctly done with Smarts. And it was just an iterative process. It took, on that particular case, took them several iterations, several days to get through it, but it was very productive, using multiple techniques in the product, and they worked their way down to essentially getting no more mismatches.
Yeah, got it. We're already over time, so first of all, we'd like to thank you for spending time with us to help us understand your product better. So thank you, Robert. Thank you, Colin, for the time you spent. Next steps, we'll have an internal meeting and see what we can do about it, and we'll reach out if we have additional queries or want additional details going through.
And one thing, and I think we had talked about this before, Raj, is you can do this in, we could set up a workspace for you. I'm not sure, maybe we already had set up a workspace, but we can set up a workspace and then work together on maybe loading some data and some rules, and then if there is a situation where you could take like a set of rules that would represent historical rules, historical data, and then data that would be coming out of a new system with a new set of rules, we could set something up where it would show a mismatch and then go through the process together as to how to create additional rules to resolve the mismatches. So we could actually do a POC with you together. You would have a workspace, and Colleen and I could work with you on getting through that.
Yeah, that is what we were thinking along. So we'll discuss it tomorrow, and I'll send you a mail how we want to take it forward.
Okay. All right. You had mentioned ODM before. If anything comes up, you probably know this. Colleen and I both had come from IBM, previously iLog, so we're pretty familiar with the product, even in its current state. And so, if there are some things that come up that you have had experience with ODM and you want to know, differences between smarts and ODM for a particular capability or area, feel free to let us know, and we'll be happy to draw a comparison for you.
Yes, sure. Even the Equifax case study, it was previously done using iLogs, as it was called, and we've replaced it now with Sparkling Logic. So we understand the context and how it is used.
Okay. Unless there's anything else.
You will be sending, Robert. You will be sending that the recording, right?
I will. I'm going to. Yeah, I'll clean some of it up because I think there was some stuff at the beginning that we don't need on the introductions, and then it'll be big enough that I'll make it available as a link.
Yeah, maybe on some server, or if it maybe, I think for the meeting server we can directly access something like that.
Okay.
Thank you, Raj.
Thanks. Thanks,
Thank you,
Ram.
Raj.
Thanks, Robert. Thanks.
Anil. Okay.
Yeah.
Bye-bye.
Thanks, Pete, for staying up late.